Lesson 67, Solve and Classify Special Systems of Linear Equations. Just a review of what a system of linear equations are. Linear equations, remember, are two equations that they can either cross or they never cross because they are parallel lines. And when we find a solution to a linear equations, the solution is always where the two lines cross. So today we want to look at three different kinds of systems of linear equations. The first one is consistent and independent. Consistent means, a consistent system just means you have at least one common solution. So in this example, consistent and independent, the independent means it crosses in exactly one place. So there is exactly one solution for this example. So consistent and independent means two lines cross exactly one place. Consistent and independent means you have infinitely many solutions. You do have at least one solution, that's why it's consistent. Dependent is because it's the exact same line. So if it's the exact same line, it's going to cross in multiple places. And in fact, it would be every single place because it's the exact same line. So any number I put in for the variables, it will work. And the last one is inconsistent. Inconsistent means that there are no solutions. And the reason why there are no solutions is because the lines are parallel. And we know that parallel lines never cross. So let's take a look at some examples here. First, looking at inconsistent systems of equations. So inconsistent, remember, means they're parallel and they have no common solutions. So how do you know if they're going to be inconsistent? So here on the right-hand side, I have two equations. We have negative 3x plus y equals negative 4 and y equals 3x. We can use the substitution method to solve for one of the variables. So since y is already by itself, if y equals 3x, I can substitute that in for y in the other equation. So now I have a negative 3x plus 3x has to equal negative 4. Negative 3x plus 3x is just 0. Does 0 equal a negative 4? No, it doesn't. So because both sides are not equal, that's why there is no solution. Or you would say that they are inconsistent. Next one. Here you have two equations where both of them are solved for y. Since they're both equal to y, I can substitute this one in for the other one. So now I have half x plus 7 equals 1/2 x plus half. And now I can subtract half x on both sides to get all the x's to one side. And I'm left with 7 equaling half. 7 does not equal half. That's why it would be no solution. If you think back to this example and the previous example, how would you know if it's an inconsistent? Well, if the term that has the variable on one side and the term with the variable on the other side, if they're exactly the same, and these other numbers like 7.5 are different, that means you always have no solution because both sides will never be equal. Because the one with the term with the variable will cancel each other off. That will always equal 0. Next example, dependent systems. Dependent means you have identical solution sets, which means they're exactly the same line. You have many solutions. So any solution you put in there will work. So let's take a look at this example. We have x plus 3y equals 6, and 1/3 x plus y equals 2. I'm going to solve for x on this top one, so I'm going to subtract 3y to both sides. And now I have x equaling 6 minus 3y. That's what x equals, so I can substitute that in for this x. And if I rewrite this, I would have 1/3 times 6 minus 3y plus y equals 2. And now I can distribute. So 1/3 of 6 is 2. 2 minus 3y. Actually, not minus 3y, so I have to distribute 1/3 times 3y is a minus 1y plus 1y equals 2. Negative 1y plus 1y is just 2. 2 does equal 2. Since both sides are equal to each other, this should be many solutions. Next one. Here we have x plus y equals 10 and negative x minus y equals a negative 10. Now the previous problem, we tried solving for one of the variables. Here I'm going to use a different method. Here I want to get both of them to equal y. So I'm going to subtract x on both sides. And when I do that, I end up with y equaling 10 minus x. The one here, I want to get y by itself. So if I'm going to get y by itself, I'm going to add x to both sides. Now I have minus y equals a negative 10 plus 1x. To get y completely by itself, I divide by negative 1. So I divide everything by negative 1. And now I have y equaling a positive 10 minus x. And since both of these are the same, you would have many solutions. As you remember, equations are the same, many solutions. Those are just two ways you can solve for it. You actually don't even need to solve for what y or x is in this example because every answer you get will work. Okay, classifying the systems of equations. Again, just a quick review. Consistent and independent, you have exactly one solution. Those are the ones that we've been looking at most of the year so far with systems of linear equations. Consistent dependent, we just went through where it's many solutions because they're the exact same line. And then we went through some inconsistent ones where they're parallel lines, the lines never meet. So now we're going to take a look at some examples here, and we have to determine which kind of system it is. So here, first off, let's put them both into y equals, because that way you can determine if it's consistent or inconsistent. So this first one, let's subtract 2x on both sides. And I have y equaling a negative 2x plus 1. And then the other one, to get y by itself, I need to subtract x on both sides. So now I have negative 1/4 y equaling a negative x plus 3/4. To get y by itself, I need to multiply by a negative 4. So now I have y equaling, multiply this whole thing by negative 4. Negative 4 times negative 1x is 4x. Negative 4 times 3/4 is a negative 3. So since the equations are not the same, I know it cannot be consistent and dependent. So it's not that one. So now let's go to the next step. Since they both equal y, let's just substitute this in for that y. So I have 4x minus 3 equaling a negative 2x plus 1. To get all my x's to one side, I'm going to add 2x. And then I'm going to add 3 to both sides. So now I have 6x equaling 4. To get x by itself, I divide by 6. X would equal reduced, so divide this by 2 halves, would be 2/3. Since I got an answer, I know it cannot be this one because for this one you cannot get an answer. So I know it's going to be consistent and independent. Because it's consistent and independent, I need to find the solution. So I found half of the solution. So I'm going to substitute 2/3 x into one of the two equations I have above. I'm going to choose this one right here. So y equaling 4 times 2/3 minus 3. So 4 times 2/3 would give us 8/3 minus, this would be 9/3. There's 3, I'd have to multiply this by 3/3. 8/3 minus 9/3, y would equal a negative 1/3. So my solutions would be x equals 2/3, y equals negative 1/3. And we said it would be consistent and independent. Next one, solve for this one. One of them, this one's already done with y equals. Let's put the other one. So I'm going to subtract 3x to both sides. And now I have y equaling negative 3x plus 2. Now if I look at this one very carefully, this one I have y equals, so I can substitute this one in for y. So if I substitute that one in for y, I have negative 3x plus 2 equaling a negative 3x minus 4. Since the term with the x variable are the same and the other numbers are different, that means it's going to be inconsistent, no solution, because parallel lines have the same slope. They both have a slope of negative 3. So I could actually stop right here and say that it is no solution or inconsistent. If I wanted to go further, I could have just added 3x to both sides and got 2 is equal to negative 4. They are not equal, so therefore it is no solution. Next one, solve for these and classify them. If I want to get y by itself, I divide this one by 4, divide by 4, divide by 4, and I get y equaling x plus 1. If I divide this one by negative 4, divide this by negative 4, divide this by negative 4, I end up with y equaling x plus 1. And since they are both the same equations, I know that it's going to be consistent and dependent. Or consistent and dependent. And I would say it's many solutions. If I want to go further, I could substitute this in for y, x plus 1 equaling x plus 1. If I subtract x on both sides, I end up with 1 equaling 1. Both sides are equal. That just verifies that I have many solutions. And the next one here, x minus 7y equals 3, 2x minus 5y equals 15. Let's just solve for, well, so let's solve for, let's just say we're going to solve for x. So I'm going to add 7y to both sides. And now I have x equaling 3 plus 7y. If this is what x equals, I can substitute that in for this x. So now I have 2 times 3 plus 7y minus 5y equals 15. Distribute, so 2 times 3 is 6, 2 times 7y is 14y, minus 5y equals 15. Combine like terms, so 14 minus 5 is 9, so 9y equals 15. Subtract 6 on both sides. We got 9y equaling 9. Get y by itself, I divide by 9. Since I get an answer, y equals 1, I know that it has to be consistent and independent. I can now find my x by plugging that in. I'll plug that in right here. So x would equal 3 plus 7, which x will give us 10. Okay, so if you didn't solve for both equations into y equals, then this would be another way, just using the substitution method. Next problem here. Solve for these and classify them. Here I have one where y equals, so let's substitute that one in for the y in the second one. So I have 8x minus 5 times 4x minus 5 equaling 16. So I have 8x and then distribute the negative 5. So minus 20x. And negative 5 times negative 5 is plus 25 equaling 16. 8x minus 20x is a negative 12x plus 25. I'm going to subtract the 25 first to save some space. So now that will equal a negative 9. To get x by itself, I divide by negative 12. X would equal a positive 3/4, because I can divide this by 3/3. Gives you positive 3/4. So since I got one answer, I know it's going to be consistent and independent. I can now solve for y. Substituting 3/4 x in, I'll put that in for this one. So y equals 4 times 3/4 minus 5. 4 times 3/4 would give us 3. 3 minus 5. Y would equal a negative 2. So there would be our answer. And we have a couple application problems. Brandon started jogging at a rate of 4 miles per hour. After he jogged 1 mile, his friend Anton started jogging on the same path at a pace of 4 miles per hour. If they continue to jog at the same rate, will Anton ever catch up with Brandon? Explain. The hint, you need to determine, will the two lines ever cross? So let's write our two equations. They both go at the same rate, so I'm going to start off both of them with y equals 4x. And we'll say this top one, this is Brandon. Bottom one, this is Anton. If they're both running at the same pace, but Anton doesn't start jogging until after Brandon has run a mile. So they're going at the same pace, but Brandon is 1 mile ahead. Will they ever catch up? Well, let's see if the two lines will ever cross. So if they both equal y, I can make them both equal to each other. So I have 4x plus 1 equaling 4x. Let's solve to get all the x's to one side, so I'm going to subtract 4x on both sides. And I have 1 equaling 0. 1 does not equal 0. Because they don't equal each other, no, they will never, Anton will never catch up with Brandon. The answer would be no, my work proves it. So if they're going at the same pace, but one person's a mile ahead, they can never catch up. Next one, emergency road service company offers different plans to its customers. Plan X offers service calls for $22 each. So I'm going to put y equals $22 per call. Plan Y offers a rate of $40 per month with an additional charge of $12 for each service. So this one would be 12x, $12 per call, plus you have to pay the initial fee of $40. For 1 month, how many service calls would it take for Plan Y to cost the same as Plan X? So I gotta see where they cost the same amount. So since they both equal Y, I can substitute 22x in for this Y. So I have 22x equaling 12x plus 40. Get x's to one side by subtracting 12x. End up with 10x equaling 40. The x by itself, I divide by 10 on both sides. X, the number of calls, would be 4. So after four calls, they would charge the same amount. And to explain it, I can just substitute the 4 in for both equations. So I have y equals 22 times 4, which y would give us $88. And do the same thing with the bottom one. Y equals 12 times 4 plus 40. 12 times 4 is 48 plus 40. Y would equal $88. So there would be my explanation, showing it with my work. And our last one here. Hannah and her mother are going on a bike ride. Hannah's mother leaves the house traveling at 13 miles per hour. So we'll say y equals 13 miles per hour. So that would be 13x. Hannah leaves the house after her mother has biked 2 miles. So let's just say this is the mom. So she's done 13 miles per hour plus she's 2 miles ahead. And Hannah tries to catch up by traveling at a speed of 17 miles per hour. So that'd be 17x. So we'll just say this is Hannah. Will Hannah catch up with her mother? If yes, when would that be? Since they both equal y, I can substitute them in for y. So I have 13x plus 2 equals 17x. You get x's to one side, I subtract 13x. End up with 2 equaling 4x. The x by itself divided by 4. X would be half, and x would be the number or the amount of time. So the time would be half an hour. So we would say at half an hour, about what distance would that be? I can substitute that in for x. So let's just put this in for half. So y would equal 17 halves. 17 halves would equal 8.5 miles. So when the mother, or when Hannah has traveled 8.5 miles, is when she will catch up to her mother. But the mother would have gone 6.5 miles from the time Hannah started because of the +2. So that is our lesson today on solving and classifying special systems of linear equations.